Hello, Hacksters! It's been a while since we had a live unboxing, so today I'm very excited to bring to you these new eval kits from Infineon. We'll be unboxing and also running a couple of demo applications on these kits. I'm very excited to share them with you. Here's a quick sneak peek. But first, I have to give you the context around this, which is we are running a contest with Infineon around human-machine interaction and the future thereof, which I have a bunch of ideas, but if you have your own ideas about how these could be used, capacitive touch sensing, very robust, durable, resistant to water, all kinds of good stuff that we'll get into in a minute. If that gets your brain running at all, you should submit your own ideas for a project to build with this so that you can be one of 100 people to win hardware to build a project. Our contest runs until February, but you have just under 2 days at this point, as of this video, to submit your own ideas and win free hardware. So go ahead and feel free to switch away to that. The links are down below in the description. And if you miss that deadline, don't worry, you can still get the hardware and submit your project by the end of February and win the contest, which has some fabulous prizes of its own. So 2 stages, you can get free hardware if you see this within a couple days and submit your own ideas. And then also, if you build something, whether you won hardware or not, and publish your project on Hackster and submit it to the contest, you can win I believe the top prize is a $3,000 virtual gift card, and there's other wonderful prizes, a speaker, I think a cool wearable as well. So we're going to take a look at those. So first up, the contest is propelling human-machine interactions into the future. This is one of our hardware contests. We've always got a number of them running. We've got some recent ones. You can see who's won in the past in case you want to tailor your stuff to what you think will win. But we always have different judges, so you can't engineer it that much. Second, if you want to see more of these unboxings and learn more about more new tech and see cool interviews with people doing awesome stuff with technology, be sure to subscribe. Just hit that button. Do it now. Okay, so propelling human-machine interactions into the future with Infineon went up to $3,000 in prizes. The challenge: we live in an increasingly digitized and interconnected world, and Infineon is at the forefront of this trend. If you want to just sit around and watch the world go by without you, you're free to simply absorb the changes that happen in technology. But I think we're all here because we're interested in helping to build and shape that future, and this is your chance to do that. So CAPSENSE-based products are found everywhere: smartphones, wearables, automotive dashboards, all kinds of stuff. And as you'll see, there's all kinds of different shapes that these things can take as well. The technology has a number of advantages. You don't need to have moving parts. It's not going to wear out over time. Also, with the lack of moving parts, it makes it easier to ship things, less worry about stuff getting damaged. I live in an earthquake area, all kinds of stuff like that. Something you want to rely on, you can use CAPSENSE technology for that. It can be completely sealed to prevent moisture from seeping in, but also for sanitation reasons. I'll get into that later. You don't require force to operate it, so again, durability results in reduced BOM cost. You can fabricate your own. The interface can be part of the product itself. You don't have to. Oh, there's so much possibility here. You don't have to get custom buttons. You can fabricate just an overlay for these things, because usually the CAPSENSE tech is sitting underneath a layer, a protective layer that can be anything. It could have braille on it. It could be in any shape that you want. So you don't have to rely on someone else's hardware stream. You don't have to be at the mercy of shipping and supplying. You can fabricate your own enclosures and interfaces and just use this underneath. And you get more flexibility in button shape, size, and graphical representation for your overall design. So creative freedom as well. I really hope we see some really creative stuff on here. Examples: high torque power tools. A smart grip detection feature could make it safer by utilizing inductive or capacitive sensing to ensure proper and safe use of the tool by looking for handle deformation and the amount of grip covered. For tools with a trigger switch, a non-contact based position detection feature like a potentiometer or whatever, but done with you could do proximity, you could use these sliders we're going to look at, can be implemented using a capacitive or inductive slider array. All kinds of cool stuff. So what underwater touch, whole camera touch, gesture control, proximity wake up? Projects built by passionate individuals who can help us realize that vision is what Infineon are looking for. So, the hardware! On to the very exciting part that we're all here for right now. We've got two different types of developer kits to give away. We've got the PSoc 4100S CAPSENSE Pioneer Kit, which is the larger one here that I'm going to have to cut open, and the 4700S Inductive Sensing Evaluation Kit. So a low-cost hardware platform. The CAPSENSE Pioneer Kit has a bit more involved interfaces and things included in it, and the 4700S inductive kit is designed to be lower cost and for designing and debugging the with the PSoc 4700S MCU. They are programmed slightly differently. You'll have slightly different developer environments, and we'll take a look at those as well. So first, the CTA. Call to action. Go to the hardware application tab and fill out the questionnaires by November 23rd at 5 p.m. Pacific. It's a very friendly form. You put in your title. You want to commit to this, though, because if you get a kit and you don't build anything, you still have a chance to let us know what's going on with that. And then we might see if someone else can get a hold of that hardware and actually build something. But in other events, if you just get something and don't build something, you may end up on our ineligible list, because we want to make sure this is going to people who are actually going to build something. So what are we talking about here? We're talking about the 4100S CAPSENSE Pioneer Kit. Let's take a closer look at that after first. You've got the PSoc 4100S device, a PSoc 4 with an ARM Cortex M0 Plus core, with both the 4th generation low-power CAPSENSE solution, up to 64 kilobytes of flash, 8 kilobytes of SRAM, 9 programmable analog blocks, 8 programmable digital blocks, and 36 GPIOs, all capable of CAPSENSE, and 16 smart IOs. Let's take a look at that one. So that's this one, which I'm going to have to open up here. Give me a second. I'm going to go straight to the knife because I don't want to struggle with this plastic. I wanted to... This is the one that came wrapped in plastic, and I wanted to save this moment to share with you all. So I haven't actually looked at this one yet, obviously. I did take a peek at the 4700S, which we'll get into in a second. And I've played around with other PSoc 4 kits. I really love... this is a bit tangential, but I do actually love the design of these kits themselves and the packaging that they come in. It's so profesh, so polished. So here we are, the 4100S Pioneer Kit, featuring the industry's most robust and lowest power CAPSENSE solution. If you haven't picked it up by now, CAPSENSE, of course, is capacitive sensing. Self and mutual capacitive sensing, easy BLE, you've got Bluetooth on there, and it is compatible with Arduino Uno. Physically compatible, and also personality-wise, software compatible. Let's always cut away from yourself. That might have already been open, I'm not sure, but it was in plastic, so probably not. Okay, so we always have these little beautiful magnetic enclosures. I know, I should focus less on that, but it's really cool. PSoc 4100S Pioneer Kit Getting Started Guide. You've got a QR code bringing you to all the information and a little getting started sequence. Connect the kit to your PC. This is very pretty. Touch the color gamut triangle to select a particular color. The RGB LED will turn on with the selected color. That's so cool! Oh my gosh! You don't need driver installation to run this, although it may continue in the background. I'm going to see if I can run this off of just USB power, so that if it requires more than that, I'm not actually going to spend time on it right now because I want to show you the rest of the hardware. But as you see, you can easily open up the plastic case, and you've got the CAPSENSE trackpad underneath there, along with all this wonderful documentation on what exactly our layout is. So let's take a look. Oh, so shiny! This is a very shiny kit. Here you've got power select, battery versus external thing. Okay, yeah. It hasn't been charged. Here's our Bluetooth symbol. We've got a little variable resistor here. We've got reset, switch 2 and switch 3 buttons. Oh, those, yeah. Oh, those are quite satisfying. Nice. Good button sense. Let's plug it in. We've got power and status LEDs and a micro USB connector. The other one is USB-C. I took a peek. So let's plug this in. I'm afraid I'm getting fingerprints all over this. Let me see if I can just run it off of a battery. Doot. Oh, yes, we have power. And can I change... Oh, look at that! You can see the color changing as I move my finger around on the gamut. We're having this... Oh! It's actually... You know what just happened? This is so low power that it's not actually keeping my battery on because it has a low current cutout. So give me a second. They weren't kidding. But I have a thing for that. Fortunately. So I have a load on here that will make sure that we have plenty of current that we're drawing to keep it alive. Okay, let's try this again. Yes, we have purple, we have green, we have red. Oh, this is so cool! Blue, cyan. And then I kind of keep tapping off of the thing so it keeps turning off. And it dynamically changes the color. That's very nice. Beautiful, right out of the box. And as I mentioned, it's low power enough that I had to add this dummy load to make sure that it actually stayed on. Wow. Then there's some other stuff in here as well. Actually, there's a water dropper, so you can prove to yourself that it still works when it's wet. And what's this guy? Oh, I think this is some breakout connectors. These are for hooking it up to an Arduino. Oh, nice. These are actually, look at these staggered pins so that you can stick it in and it will stay in place. Friction fit. So you don't need to mess around with tinning those. Okay, and then also we have some jumper wires. Breadboard jumper wires. So let's actually take this open. I think that's all that's in here. Yeah. Well, okay, first I'm going to be a jerk to it. I am going to put some water on there. Let's get it wet. Avoiding all my plugins and stuff. And we still have positive function. It works, ladies and gentlemen, and everyone in between. It totally works. Do the thing. There we go. Cool. I may be interfering with it. Oh, shouldn't tip that into there. Someone's asking what the dummy load is. Any specs? I actually don't remember off the top of my head, but I can look it up and put it in the comments later on. Thank you for asking, Naveen. There's definitely several different ones that you can get. I have another one that looks like this. Just look for Keep Alive or dummy load or current draw, something like that. Okay, so there's instructions here now that it's kind of dry. I really shouldn't have put that in there, but I will. There are instructions for how to get the little case open. Pull out the bottom case by inserting the finger in the notch provided. There's a notch that's provided. Is that this? Yes. And then remove the bottom case by gradually moving the finger along the edge of the bottom case. B. I might need some stronger fingernails for this. Or like a, I've got an iFixit electronics repair kit that might be better for prying this apart. For now, you can take my word for it that there's an Arduino inside of here, or there are Arduino headers inside of here, rather. You can see them on the diagram, so you can connect stuff to it. All the pins are labeled. You can see what the trackpad and the buttons look like inside. So it's actually ready to use pretty much as like a mouse or whatever. With a proximity sensor loop. They have some more info on the website that will give us more about that. If you just click through on on the links that are in the description to the video, you can see the gamut, color gamut demo. And then flexible prototyping, you've got a rechargeable coin cell battery in there, you've got the potentiometer slash variable resistor built right in, you've got the easy BLE PRC module, PSoc, is that what you call it? And drag and drag programming. Here you go. So you can use it as a finished product that implements a USB or a Bluetooth mouse. Here you go, for press fit connectors, for jumper wires, etc. Scroll down for more information on this one. I took it upon myself to look up the design and development tools. On the contest page, there is a ton of information. So there's this webinar, getting started. It's directly underneath the information about the hardware kits. Also, actually, you don't even have to use these specific kits. You can use other PSoc 4 and PSoc 6 devices. You're not limited to these ones. So even if you don't win hardware this round, you can build your own project with these or with other kits, and it'll still be eligible to win the fabulous prizes that we'll see in a second. But first, yeah, resources. We've got this Getting Started webinar, covers an overview of the CAPSENSE solution, applications for CAPSENSE, and a demo showing how to implement it using Moto's Toolbox. We'll look at that in a second, on the PSoc 62S2 Wi-Fi Bluetooth Pioneer Kit. Prizes! I mentioned that $3,000 e-gift card. Again, you have until February 28th, 2023 to submit your projects at 5 p.m. Pacific. So be sure you hit that 5 p.m. Deadline. But yeah, until the end of next February. So all these fabulous prizes could be yours. Second place gets a Sonos 5 speaker. Third place gets a Garmin Vivo Active 4 wearable tech device for fitness and such. We've got judges who will be joining us from Infineon. More resources down here. This is what I wanted to show you. There's more information on CAPSENSE controllers in general. There's this design guide, which is what I'm looking at right now. Actually, is it this one or the other one? This is the other. Okay, so this is the design guide. Whoop. And down here you can find information on gesture sensing, touch gesture support, gestures supported by different CAPSENSE widgets. And then the design and development tools, which is what I had just showed us a second ago. This is where you figure out which development tools you're going to use in order to develop your application. So this might be something that you want to look at before you submit your idea. Moto's Toolbox and PSoc Creator are not available for use on both of these kits. The second one I'm going to show you in a second, the PSoc 4700S, is going to be using PSoc Creator, which is, I believe, Windows only. But Moto's Toolbox, the one that this kit uses, the 4100S kit, is available for Windows, Linux, and Mac OS. So just be sure of what you're getting into there. This design document is linked in the it's linked on this page, on the contest page. And it gives you all kinds of different information about the kits. So the design and development tools, we're going to talk about Moto's Toolbox. They have this informational page about it, including info on machine learning you could integrate into your project, but also they've got this video that I was watching, which really shows you the breakdown of what it consists of. It talks about how you can use it on all the different platforms, Windows, Linux, Mac. And then also they tell you about, there's these drivers for working with this different hardware. Then there's libraries. For example, with CAPSENSE is going to be a library that you're going to use with Moto's Toolbox. Graphics, connectivity, security, voice and audio, machine learning, and Wi-Fi and Bluetooth libraries. Those are all things that you're going to use in Moto's Toolbox. They have code examples and reference designs built in, and then there's all these interfaces that you can interface with while creating your project creator, library manager, Eclipse and partner IDEs, etc. I'm not going to read all of this to you. You can go look it up yourself. But I got excited by the fact that there's so many resources available. Now let's take a break. A quick breath. We're going to open up our second kit here. I'm going to begrudgingly put away the first one. And we're going to take a look at the 4700S Inductive Sensing Evaluation Kit. And this one is actually going to be a little bit of an adventure because I think that during transit, one of the pieces of this kit knocked off another piece. There was I'm not putting anything in that wet spot. There's an LED that I think came off of this kit while in transit because it includes a little metal proximity device. And I think it knocked off one of those SMD LEDs, but we might actually be able to reattach that. So I'm going to turn on my soldering iron, and hopefully by the time to do the demo, I'll be able to reattach it, and we'll do the whole demo, but we'll also get some fun soldering in. So yeah, this is the COI8C kit -148 evaluation kit for the 4700S PSoc inductive sensing. So you've got 3 inductive sensing button coils, 1 inductive sensing proximity coil, and an FPC connector, a flexible PCB connector to evaluate various other interfaces. So you could connect, another type of variable resistor, potentiometer, or whatever. This one comes with a USB A to C cable. So the other one is micro USB. This one is USB C. Let's take a look. Oh, there's that LED. We've got this quick start guide again. Very nice. This one doesn't have nearly as many things to label, but you've got a block diagram on here and a guide to, I'll put this with the other kit, and a guide to what all is on here. Underneath here on the left is your flexible PCB connector. Whoop. You've got your USB connector, a little jumper. What is that actually? VDDD and VTARG. Probably voltage. Yeah, up here you've got programming and debug header. You've got various LEDs for interaction. You've got these 3 LEDs which interact with the buttons. Your PSoc 4700S target device on here. You've got communication reader connector, or communication header here for communicating. Power LED, reset switch, status LED up here, and a mode switch here. Programming and debug header we already talked about. That might be about IO header over here. That's about it. And then your proximity sensor and your buttons. And the proximity sensor is for use with this metal target here. So we'll be doing something with that in just a second. And I'm going to solder this LED back on. Where's my tweezers? So let's see, which way are these going? Green dots to the top, okay. Oh, I hope it didn't rip off the pads. That looks a little shady right there. Ooh, ouch. It kind of looks like it did rip off the pads on that LED. Oh, dang. Oh, that's too bad. It would have been fun to do a quick little repair here. But it's looking pretty grim for our friend. I'll try it anyway. I can't resist a challenge. Okay, so we're gonna retin these pads. I know, this isn't technically part of the unboxing, but it's part of it, because what if you come across the same issues, You gotta be ready for anything. So I'm gonna retin that top one, and we did have a piece come off here, which I'm afraid might be the LED connector pad. We'll see. Okay, so green dots to the top. I've only tinned one of the pads because it's easier to solder surface mount stuff that way. Okay, why did I pick this up in my left hand? I've been such a fool. Also, why did I tin that one when I need to do this? Should have tinned the other pad. Okay, are you going to connect? Ah! I've made things so hard for myself. Okay, we're doing it this way because it makes a little bit more sense. Oh, but it is actually holding on there, so maybe it'll work. Oh, I have hope. Okay, so I'm going to double check that the pads are aligned the right way. Yes. It looks like it might be a little bit chipped as well, which doesn't really surprise me given that there was enough force to knock it clean off the board. Oh no! Oh no! Go back on there! Oh dear. Oof. Dots are still aligned. Okay. Ugh. Surface mount soldering. There we go. It's gonna be messy, but it should work. Okay. Is that sideways? No, it's good. But it's a little bit bridged. Okay, let's try that. Okay, we'll see if that LED actually comes on during the demo. If so, I demand mad props. We will see. Oh, my... See, you might not actually want this particular dummy load because it is gripping very strongly onto my USB. But maybe that's a good thing. Okay, so now... yeah, Ginger, be ready for anything. That's how we do on Hackster. Of course, this is just our YouTube channel, but we have, as you've seen, contests and projects and all kinds of other cool stuff to look at. Okay, so... I don't see any LEDs coming on. Okay, that's bad. I should have... what I should have done is turn it on first so that you could see that I wasn't going to wreck anything by adding that LED, because I'm definitely certain that it wasn't adding that LED that did this. But for some reason, we're not getting it on. I'm going to attribute that to the fact that, that my battery has gone off. Ha! There we go! Yes! Okay, so we've got some... We had a little trill of LEDs going there. I'll try and show you closer up. Where is my... Here we go. We'll get some better focus on that for you. Yes. Okay, so we're gonna reset it again. Oh, that might have actually been proximity. Oh, it's because I had my hand on the back of it. Okay, so we've got this metal device, which is giving us this proximity readout. It's an analog readout. I mean, technically it's digital, but it's not just on and off. It's like progressive. Very good. Okay, moment of truth. Is this gonna come on? Yes. Okay. Button 1. We'll see if my fix worked or not. Button 1. Button 2. Button 2. Ooh. That one doesn't want to come on. So I might not blame myself if the third one doesn't... Oh, the third one comes on! Oh, that's the one that... Sorry for the yelling, but that's the one that I just fixed. That's the one that got knocked off in the box in transit, and I just reattached. Button 2. Okay, so now this is a challenge. Now I have to fix button 2 as well. I'm going to resolder that one and see if it helps. Oh yeah, you know what? That looks like a cold solder joint. That's not well attached at all. Okay, I'm going to commit a crime here and solder this with it plugged in because I am bad like that. This is what you get with a live demo, folks. Live unboxing, live demo, live soldering when you didn't expect it. Ooh! Ha! Getting some proximity readings off the solder here. Oh no, it's not the solder. Maybe it's the soldering iron. I'm gonna be honest, this is really fun. I've got some ideas for what I would build with this stuff, and I want to see what y'all would do. Oh no, still not working. Maybe that LED is just sad. Oh well. At least I feel validated because the one that I fixed totally works. Okay, so everyone, that is the CY8C kit -143 evaluation kit for the 4700S inductive sensing evaluation kit. And then you've got this, you got a mode button up here that changes the mode, which I don't know if that actually is programmed to do anything right now. Seems about the same. You've got these I/O pins over here. You've got communication headers. You've got this flexible PCB connector over here, which you're probably familiar with, especially if you've worked with things like Raspberry Pi cameras and such in the past. All kinds of cool stuff on here. That is the second kit that we are looking at. And then there also is a third kit. I'm going to unplug this now and turn off my soldering iron and put everything away. There is a third kit, at the risk of rambling. The CY86C kit -148 Coil Inductive Sensing Coil Breakout Board Quick Start Guide. This has a bunch of different sensors sort of already set up for you. I'm going to peel here to open it up. This is a really interesting, another packaging option that Infineon sometimes uses. Let's get that focus back on track. Okay. Yeah, and you can just, it's almost like a postcard kind of setup, but you can check out all the contents on there. COA8C kit -148/-coil. You get all this information. This one has a rotary target included with it, like that metal target in the other one. You're going to slide it over the different interfaces. Woo! Yeah, and then you've got a flexible PCB connector over here. Oh yeah, come out of there. It doesn't want to. Too bad. My tweezers win. There we go. And I believe you could use this with the flexible PCB connector on the 4700S kit. Jump. Same size. Oh. And we have, oh my gosh. Ha! PSoc rocks. Indeed. So we've got a button and proximity sensor, these different rotary encoder sensing. Here you can see on this rotary target that it's got a coil, or maybe that's a magnet, or even just a ground plane. It's probably a ground plane on here that you can stick into here, and then it'll be able to sense different stuff. Woo! Because you can see these 3 different sectors on here. Nothing, rotary encoder 1 and rotary encoder 2. Then we've got these a linear encoder going in increasing sensitivity, and then linear encoder going the other way. So tight coils over here, loose coils at the other end, and vice versa. Metal target to target. I think you can break this off. They say to like break it off in the instructions on here. Let's take a look. Slide metal target 1 over SQ1 to SQ6, which are these little targets. As you can see, there's all kinds of different types of sensors that you can build with coils and things. These are designed, intended as inspiration to sort of get your mind going about what you could build. And yeah, our team came up with some ideas. I have some personal ideas as well. So, for example, the fact that these things are going to be embedded under a solid surface, right? You'd put this under something clear or opaque, and that can be especially like a laser cut acrylic type situation, something 3D printed, anything like that, and it can look like anything that you want. Plus, if you make it a flat surface, it can be completely sealed. So sanitation is good. Ideas I had for that were like museum exhibits and interactive art exhibits. I've got a number of friends who do really cool stuff that ends up in public displays or in museums. And durability is always a factor. Sanitation is always a factor. So this kind of an interface is kind of perfect for that. Even wearables, maybe. Tactile interfaces can be very custom with this type of kit. You could put Braille on top of it. You could fabricate your own 3D printed cover with Braille on it to indicate what was going where, or other types of indicators. And since they are dynamic controls, check out all the different types of options you have here. And these are just suggestions. You could come up with a completely different type of sensor that isn't even represented here. So you could use them for game systems, a custom game system, an accessible game system, or for a type of system of game that hasn't even been dreamed up yet, a VR controller, something like that. or a musical instrument. All these different options for things that you could build with this kit. It's very exciting for me, honestly. So those are the 3 pieces of hardware that we have. I wanna make sure that we, wrap this up quickly because I could go on about it forever. But yes, we have the, product page is linked below in the description. You can look up more of the details about each of these eval kits, including the types of, connectivity that they have, micro USB, USB-C. The other kit has Bluetooth, and things like that. Just tons of cool information. As I mentioned before, we've got this design document, which is linked in there. Also, be sure to check out whether your target hardware uses Modus Toolbox, which is cross-platform, or PSoc Creator, which is a cool piece of software. It's an IDE for you, but it is Windows only, from what I have discerned from their websites. Project brief. Pardon me. User manual. Getting started with PSoc 4. There's just all this different stuff, and there's also in the Getting Started with PSoc 4 document, which is linked at the bottom of the contest. It might actually be on one of these product pages, but it's very easy to find, I promise you. There's just almost an overwhelming amount of information for getting started, and so you can scroll through to find the specific links. But yeah, on the Getting Started with PSoc 4 document, you have both my first PSoc 4 design using Modus Toolbox, which we talked about before. You can use it with Eclipse IDE as well. Forgot to mention that. But also my first PSoc 4 design using PSoc Creator. So you can take a look at both of those workflows from this document, which is Getting Started with the PSoc 4, either one. And it's got a full list of which ones are supported. Before we wrap up, I want to make sure that you see that there's already a ton of Hackster projects using Infineon CAPSENSE, all these different ones with Arduino and such. This is linked in the contest. You can look for PSoc 4 CAPSENSE or whatever. Liquid level sensing, interesting one. Another application for that waterproof container option. Tons of cool stuff. Look at this SciCube Touch. Reincarnation of Rubik's Cube is a 3D printed version with PSoc CAPSENSE and WS2812B illumination. Cool. WS2812B is pretty much the same thing as a NeoPixel, if you're familiar with NeoPixel strips, NeoPixel individual pixels and such, RGB LEDs. I also had to mention that back in 2016, I built a PSoc 4 project that did have CAPSENSE integrated into it. It was arguably my first companion bot, even before Archimedes. And it was just a little emotional robot that was kind of inspired by Eve from or Eva from Wall-E, and had a proximity sensing wire coil in there that was literally just a whisker of wire that I put in there. You don't have to go all fancy with PCB coils and such and fancy copper layouts. You can do liquid level sensing. You can do literally a copper wire that you stick in your robot and it can tell when people are nearby. And it had little 7-segment IOs and such. I think it was super cute. But I ended up using that as a demo and taking it to a couple of events that we might have seen each other at. Finally, make sure that you apply for free hardware within the next couple of days. So if you see this after 5 p.m. Pacific on November 23rd, you missed that chance, but there's still a chance to submit your own project by February 23rd, 2023. That's a lot of time. You can order one of these kits, or you can use any of the other compatible PSoc 4 or PSoc 6 hardware kits. Check that out. They're all eligible, and you can win that $3,000 e-gift card, or that Sonos speaker, or that wearable fitness device. So much cool stuff. Just be sure that if you apply for hardware, you're actually going to build something, because we want to make sure that the people are building stuff. That's the whole deal. Yeah. Ginger mentions Windows only. As I mentioned before, that is the PSoc Creator is Windows only. The the Modus Toolbox software says in the video that it supports Windows, Linux, and Mac OS. Let's just check that out somewhere in here. You can find more info on the in this video, but I forget where exactly it was. I'm not gonna make us all watch this 4-minute video right now, but thank you all for watching. I am very excited to introduce this contest. I've been looking forward to opening these kits for a long time, and like I mentioned, I have fond memories of a previous PSoc 4 kit, and I think that you're gonna love these. They come in such cool containers, and you can just use them right out of the box with all these cool demos and such. Where did that metal proximity thingy go? It was so cool. I might have put it away. Just, yeah, be sure that if you're at all interested, go check out the page. And you have nothing to lose by just looking it up, taking a look at all these cool, shiny things that you can build interfaces of the future with. Musical instruments, game dev, and game interfaces, all kinds of human-machine interfaces that can be secure and robust and low cost and water resistant and good for sanitation, and just like so many positives to this technology. Like I imagine it in space, because you need everything to be kind of like self-contained and easy to sanitize, and it's not gonna freak out too much in if you launch it from the Earth. This is totally space tech, and I can't wait to see what y'all are going to build with it. Thank you for watching. Be sure to submit your ideas and or get some hardware and build your project. I think you're going to have a lot of fun playing around with it like I just did. And as always, hack on.